Today we're going to start section 5.4, solving compound inequalities. The first type of compound inequality that we'll solve is an inequality containing and. When considered together, two inequalities such as h is greater than or equal to 52 and h is less than or equal to 72 form a compound inequality. A compound inequality containing and is only true if both inequalities are true. Its graph is where the two inequalities overlap. This is called the intersection. The solution must be a solution of both inequalities or the compound inequality has no solutions. The intersection can be found by graphing each inequality and then determining where the graphs intersect. Now this sounds a lot harder than it actually is. All of you are able to solve inequalities easily, and once they're solved, what you need to do then is just graph all of them and then just determine where the two intersect. And this is the case only in the and compound inequalities. In example 1, we'll solve and graph an intersection. We're going to solve y minus 3 is greater than or equal to negative 11 and y minus 3 is less than or equal to negative 8. Y minus 3 is greater than or equal to negative 11. We'll add 3 to both sides and we get y is greater than or equal to negative 8 as the solution. For y minus 3 is less than or equal to negative 8, we'll add 3 to both sides, and the solution is y is less than or equal to negative 5. What we want to do then is to show our solution with the y in the middle. In this case, if we start with the smallest number, negative 8 is the smallest number. And if we wanted to put y on the right side of our inequality here, we could do that by flipping our symbol and putting y on the right side. So negative 8 is less than or equal to y, and y is less than or equal to negative 5. In set builder notation, that would be for all numbers y, such that negative 8 is less than or equal to y, which is less than or equal to negative 5. In graphing then, because they're both either less than or equal to or greater than or equal to, we'll have a closed dot. On the first one, a closed dot on the negative 8, and all of the numbers that are to the right of negative 8 would be greater than negative 8. For the second one, it would be y is less than or equal to negative 5, so a closed dot on the negative 5, and all the numbers to the left would be smaller than negative 5. And where the two of these intersect is between the negative 8 and the negative 5. That would be the answer. Let's try one together. In guided practice 1, we'll solve and graph an intersection. Now this one looks different than the one in the example, but it is still considered an intersection or an and compound inequality. So we need to solve both inequalities here. The first one is 6 is less than or equal to r plus 7. And the second one is r plus 7 is less than 10. And we know these are and. So here we'll subtract 7 from both sides. And 6 minus 7 is negative 1, so negative 1 is less than or equal to r. Here we'll subtract 7 from both sides, and we get r is less than 3. Now this one is easier to write the answer because it's already in the correct form, so it would be negative 1 less than or equal to r is less than 3. Or for all numbers r, such that negative 1 less than or equal to r less than 3. To graph these, we'll first graph negative 1 less than or equal to r. Now, to graph it, we really need to switch the r to the left, so we're going to have r is greater than or equal to negative 1 because we had to flip our symbol. So, because it's a greater than or equal to, we'll have a closed dot on the negative 1, and all the numbers to the right are greater than or equal to negative 1. For r is less than 3, this time we'll have an open dot on the 3 because it's less than, and all of the numbers to the left are less than 3. So our intersection is going to be negative 1 closed dot, 3 open dot, and all of the numbers in between. Now it's time for you to try some examples on your own. In self-check 1, you'll solve and graph an intersection. You can show your work on the back of your notes paper, and graph them on a number line on the back of your notes paper, and then show your answer on the front of the notes. The second type of compound inequality is an inequality containing OR. A compound inequality containing OR is true if at least one of the inequalities is true. Its graph is a union of the graphs of two inequalities, so its solution is a solution of either inequality, but not necessarily both inequalities. In example 2, we'll solve and graph a union. A plus 1 is less than 4, or A minus 1 is greater than or equal to 3. For the first inequality, we'll subtract 1 from both sides, and we get A is less than 3. For the second inequality, we'll add 1 to both sides, and we get A is greater than or equal to 4. Once again, we'll write it in set builder notation. This time we'll write it as for all numbers A, such that A is less than 3, or A is greater than or equal to 4. You do need the OR in the answer. So graphing the first inequality, A is less than 3, we'll have an open circle on the 3, and all the numbers to the left are smaller or less than 3. For graphing A is greater than or equal to 4, we'll have a closed dot on the 4, and all the numbers to the right are greater than or equal to 4. For the graph of the union of the two, we'll have an open circle on the 3 with the arrow to the left, and a closed dot on the 4 with the arrow to the right. So this one would be your answer. Let's try one together. In guided practice 2, we'll solve and graph a union. X is greater than or equal to 9, or 2 plus 4x is less than 10. In this case, they've already solved the first one for us, so we have x is less than or equal to 9. We'll go ahead and graph that one on our number line. So we have 9, less than or equal to means we'll have a closed dot, and all of the numbers to the left will be less than or equal to 9. We need to solve 2 plus 4x is less than 10, so we can graph it. So we'll subtract 2 from both sides. 4x is less than 8. Divide both sides by 4, and x is less than 2. So to solve this one, or to graph it, we'd have a 2, and we're going to have an open circle, and all the numbers less than 2. The answer is going to be for all numbers x such that x is less than or equal to 9, or x is less than 2. So when we graph this one, we're going to graph it with the circle on the open circle on the 2. That's not a closed circle. Let me see if I can erase that. All right. Open circle on the 2 and all of the numbers to the left, because that's going to include the graph of x is less than or equal to 9 as well. Now let's try one of the OR compound inequalities on your own. In self-practice 2, you'll solve and graph a union. Once again, you can show your work on the back of your notes paper and do your number lines on the back of your notes paper and show your answer on your notes.